Okay, so let's read through one Delta Math example together. Samantha is signing up for a gym membership with a one-time fee to join and then a monthly fee to remain a member. The total cost of the gym membership over t months is given by the function c of t equals 35t plus 150. What is the slope of the function, and what is its interpretation in the context of the problem? Okay, so looking back at the equation, it's a little bit different than the first example I showed you, but we still have our output on the left side. This time it's using function notation, so it says c of t. And then we have on the right side of the equation 35t, which is the input, the variable, plus 150. So the coefficient in front of the variable, the number that's in front of the variable, is going to represent the slope of the function. And then the constant with no variable attached to it, that's going to be the y-intercept. Thinking back to the example on the first slide of this lesson. So 35 would be the slope, since it's in front of the t. It's in front of the variable. All right. We also know that thinking to the context of what this equation is representing, Samantha's joining the gym. She has this one-time fee to join. So she signs up, and they say you have to pay the certain amount. And then after that, once she's a member, she just has to pay like a smaller monthly fee in order to be able to use the gym every month. Okay, so one of these numbers is going to represent the one-time fee, and one of these numbers is going to represent the monthly fee to remain a member. So the number, the slope, which is next to the variable, is going to represent the monthly fee, because the slope is always some sort of rate of change. It's always some number that's representing change over time. So with each additional month, she's paying $35 more. So there's a change over time. That's a cost that she has to pay again and again and again and again and again. Every single month she has to pay $35 to maintain her membership. So in this case, it represents the monthly fee. So it's some sort of rate of change. It's an amount that and all that means is it's something that happens over and over and over and over and over again. It's not just like a one-time initial value. The 150 is going to represent the initial value, which would be the one-time fee to join, which makes sense, right? She's paying $150 to join. That seems reasonable. And then she's paying $35 a month after that. But the other way wouldn't really make sense if you think about it logically. Okay, let's do one more together. Cool. So you can see this is a good representation, because you can see, okay, when she first joins the gym, the total cost of membership is just the 150, the amount she has to pay to join the gym. And then each month after that, she has to pay $35 more to maintain her membership. So after 1 month, she's paid $185 in total, because she's paid the initial 150 plus the monthly 35. And this is a really common cost structure for lots of different examples, as you'll see in this Delta Math practice. Okay, let's do one more. The weight of a newborn baby, t months after birth, can be modeled by the function w of t equals 125t plus 6. What is the y-intercept of the function, and what is its interpretation in the context of the problem? Okay, so the slope is the number next to the variable, The y-intercept is the constant, the number that's separate, that doesn't have any variable attached. So 6 is the y-intercept. And the y-intercept is always like the initial value or the starting value, similar to how we thought about starting values when we were doing exponential functions. So if it's the initial value or the starting value, it's going to be the weight of the baby at birth. So it's like this constant number. The baby is going to be born at 6 pounds, which kind of makes sense if you think about how much babies typically weigh. And then each month after the birth, the baby is going to gain 1.25 pounds. But the starting value, the initial value, is 6, the weight of the baby at birth. Okay, continue to practice this Delta Math on your own if you haven't already completed it for algebra. And then you'll try some practice problems in the next slide.